Hey guys, it's Sophia again. I'm back again doing some general chemistry practice problems with you guys. Today we are going to be focusing on chapter 10 of our general chemistry curriculum. There are several different topics in chapter 10 that I could have chosen to focus on, but for this specific problem we are going to be just calculating the molar mass of an unknown gas. So we'll be doing that for our problem. What you're going to need for this problem, you are going to need a calculator, a piece of paper, and a pencil. You are always going to need a piece of paper and pencil. It's just easier to do it on a piece of paper and write it out. Easier to remember that way instead of just doing it on your calculator. So once you guys have all those, we are ready to get started. Okay, so our question is: a sample of an unknown gas is vaporized at 122 degrees Celsius. The gas that is produced has a volume of 839 milliliters at a pressure of 2.00 atmospheres and weighs 0.704 grams. We are just going to assume that the gas behaves as an ideal gas under the conditions that were given, and we're just going to calculate the molar mass. So the first thing I like to do is I'm just going to write what our givens are. It just helps me visualize. And then I think this is always a good thing to do, just so you can see it instead of looking at the entire problem. So our givens are going to be 122 degrees Celsius. We are also given 839 milliliters. So we're just going to write that down as well. The next thing we are given is 2.00 ATM. And ATM just stands for atmosphere, so just keep that in mind whenever you're doing an equation and see ATM. And our next and final variable that was given in our problem is going to be 0.704 grams. So once we have that, I'm just going to focus on this first part of the problem that says a sample of an unknown gas is vaporized at 122 degrees Celsius. The reason we're focusing on this is because we are going to have to convert Celsius to Kelvin. So to be able to convert Celsius to Kelvin, you are going to so to get to Kelvin, you are going to need to add 273.15 to the degrees Celsius that you have, or that was given in the problem. So once you have that, and we do know in our problem we are given 122 degrees Celsius, so we're just going to add 273.15 to that. Once you put that into your calculator, you're going to get that it equals 395.15 degrees Kelvin. So now we are just going to jump into the rest of the problem and solve. So for this, we are going to need to know what the ideal gas formula is for the law. And the ideal gas law formula is going to be P times V equals N times R times T. So that's going to be our basic ideal gas law formula. So now we're just going to look at our givens, and we are going to figure out what our variables are. So P is going to equal 2.00 ATM, because that's our pressure. Next, we are going to move to V. V is going to equal 839 milliliters. The only problem we have with this is that we are going to need to do a conversion. So we are going to convert the milliliters to liters. So we are going to get our new final volume is going to equal 0.839 liters. So once we are here, I'm actually going to start highlighting what our final variables are that we're going to be plugging into the problem, so it's doesn't look as confusing. So now that we are here, we are going to move on to R because we are solving for N. R is always going to have a specific given value, and that's going to be 0.0820574. It'll be the same value every single time you're doing one of these problems. So just keep this number in mind, and it's a good number to know as well. So the next thing we have is going to be T, and we solved for T just before we started doing this when we were transferring Celsius to Kelvin. So just put that value that we just found in, and that's going to be 395.15 degrees Kelvin. So to make it a little easier, we're just going to look at the equation that we are given for the ideal gas law one more time. This is because we are solving for N in this problem, so we're just going to switch around this equation to make it a little easier when we are solving. So we're just going to rewrite this our original equation out. So it's going to be PV equals nRT, and we are going to have to divide both sides by nRT. So, and then just keep in mind that we're solving for n. That's why we're dividing both sides by RT. So our new equation that we are going to get is going to be PV over NRT, over RT is equal to N. So once we have that, we are just going to plug in all the variables that we were highlighting before. So our p-value that we have found is going to be 2.00 ATM. So now that we have that, we are just going to write that down. Once again, writing down helps you remember it. So I do honestly recommend writing it down, everything you do. So we're going to do 2.00 M, and then we know our V value is going to be 0.39 liters. So we're going to, 0.839 liters. So we're just going to write that down. We're going to divide that by our R value, which is going to be 0.0820574. And we're also going to multiply that value by 395.15 degrees Kelvin. And that is going to, so once you put that into your calculator, you are going to get that the final value that you are going to get is 0.051750221 moles. So we solve for moles, and just remember molar mass is given in grams over moles. So if we look back into our givens, we're actually given a gram value, and that gram value is going to be 0.704. So we're just going to write that down. We're going to write 0.704 grams, and we're going to divide that by the number that we just got, which is 0.0517502221 moles. And then once again, you're just going to put that into your calculator to get your final number. You're going to get 13.603.80635, and then this will be grams over moles. Don't worry about sig figs right now. We are going for our final answer. We are going to do correct sig figs, as you always should do that. So our answer is going to be 13.6 because we only have 3 significant figures. Perfect. So now we are finally finished. Good job, you guys.